There's a hidden language that shapes almost every single decision in our modern world. And no, it's not code, it's not finance, it's statistics. And trust me, it's way more interesting than just math class. It's really this incredible story about how humanity went from just counting things to predicting the future. All right, so here's how we're going to break down this story. First, we'll look at its ancient roots as a tool for empires. Then we'll meet the geniuses who turned it into a science of prediction. After that, we're going to get into the nitty-gritty of how to tame chaotic data. And finally, we'll see how this hidden language is all around you, right now, every day. So first up, an ancient tool of power. Because you've got to understand, statistics wasn't born in some quiet university lab. It was literally forged in the halls of government as a way to rule.
But before we get deep into that, let me throw a question at you. What's the one single idea that connects the rulers of ancient empires, the thrill of rolling dice, and the life-saving drugs in your medicine cabinet? What ties all that together?
The answer is statistics. And the word's origin pretty much gives the whole game away. It comes from the Latin status, the Italian statista, and the German Statistik, all of them basically meaning political state. So from the very beginning, this was the science of running a state. And for thousands of years, this is all statistics was, really. Counting stuff. I mean, we're talking way back, 300 BC in India. Rulers were collecting data on births and deaths. During Akbar's reign, they were doing detailed surveys. And by the 17th century, governments all over the world depended on this data, counting people, land, wealth, to figure out who to tax and how to build their armies. It was pure information for control. But then, something totally incredible happened. We made this huge leap from just counting what is to actually predicting what could be, and this is where we meet the pioneers of probability. So in the middle of the 17th century, a group of mathematicians got really fascinated by games of chance, gambling, and they accidentally started a revolution. They came up with the theory of probability, and that shifted statistics from just a descriptive tool to a predictive science. They weren't just counting soldiers anymore, they were trying to put a number on uncertainty itself. And this whole revolution was driven by some seriously brilliant people. It really kicked off with Pascal, who laid the groundwork for probability. Then Bernoulli wrote the first ever textbook on it. You had giants like Laplace and Gauss building on all that work. But the real key figure, the guy who brought it all together, was Sir R.A. Fisher. We call him the father of statistics for a reason. He's the one who took all this theory out of the abstract and applied it to the real world, in farming, in genetics, you name it, making it the essential tool of science we know today. Okay, so that's the backstory. But how does this stuff actually work? How do statisticians look at a world of just chaotic information and pull real meaning out of it? Well, let's talk about how to tame data. It all boils down to one core idea. You've got the population. That's the entire group you want to know about, like every student in a country. But you can't talk to everyone, right? So you take a sample, a smaller representative group. And the magic of statistics is using that small, manageable sample to make some amazingly accurate conclusions about the whole population. So let's say this is our sample data, a list of test scores for 100 students. Just look at it. Right now, it's just a wall of numbers. It's messy, it's raw, and it tells us absolutely nothing. It is pure information chaos. So where do you even begin? How do you possibly find a story buried in all of that noise? Well, the very first move is to impose some order. We group the raw scores into logical buckets, creating what's called a frequency distribution. So instead of 100 random numbers, we can see clusters. How many students scored between 45 and 49? Oh, 22. Just like that, the first hint of a pattern starts to emerge from the mess. And the next step makes that pattern impossible to miss. We visualize it. By turning that table into a simple bar chart or a histogram, the numbers transform into a picture. And our eyes immediately go right to that big central cluster of students who scored in the 40s. The chaos now has a clear, understandable shape. But what if we wanted to describe that whole shape with just a single number? Well, that's where measures of location, or central tendency, come in. It's all about finding that one value that best represents the center, the typical experience of the entire group. Now, to find that center, we've got a few tools in our toolkit. And the most important thing to know is that each tool tells a slightly different story. You've got the mean, that's just the average you learned in school, and it's great for evenly spread out data. Then there's the median, which is the number smack dab in the middle. It's way more reliable when you have a few really high or low scores. And finally, the mode just tells you the most popular choice. Picking the right one all depends on what you're trying to say about what's typical. So we have these ideas, sampling data, organizing it, finding the center. How does this actually build the world around us? Because believe me, these aren't just concepts for a textbook. They are the fundamental building blocks of modern life.
This hidden language is absolutely everywhere. A drug trial for a new medicine, that's using a sample to understand the effect on the whole population. When a company forecasts how much product to make, they're looking at the mean or median of past sales. From farmers figuring out crop yields to governments setting economic policy, they are all using these exact same principles to find order in the chaos and make really important decisions.
So the next time you see a news report, a scientific study, or a business plan, you'll know the secret. You'll know it's all just a story being told with data. And now that you can see the basic patterns of this language, the only question left is, what hidden stories are you going to find in the world around you?